All right, so here we are still in Unit 1, moving on to properties of polynomials. And when we talk about polynomials, polynomials is kind of a generic term just to let you know how many terms there are in an expression, right, or in a polynomial. So polynomial just means multiple terms, but that's not always the case. So we have specific names to describe things based on how many terms they have. So this is how we categorize our expressions. So a monomial basically means we have one term, right? Mono. We have one term. A binomial, right, means that we have two terms. A trinomial means that we have three terms. See how easy math is, right? And then a polynomial means that we have many terms. So we use specific names, monomial, binomial, trinomial, up to three terms. And then after three terms, we're kind of like, it's a polynomial, okay? Which just means multiple terms. So this is for, let's write here, multiple terms. And this is basically anything larger than three terms, okay? Any nomial can be called a polynomial. That's kind of our generic term, but we do have these specific ones that you'll see in your homework. It'll say multiply the two binomials or, whatnot. So I have some practice down here, and I want you to take a second and just write out here. I want you to name that nomial, okay? Tell me if it's a monomial, a binomial, a trinomial, or a polynomial based on the number of terms. And remember, terms are the little expressions that are separated by plus and minus signs. So I'm going to give you just a second. Go ahead and pause your video and fill that in, and then we'll go over it. All right, so let's go ahead and go over them. The first one is a trinomial because you can see here we have 1, 2, 3 terms, right? Terms are what's being separated by the plus and minus signs. Number 2 is a monomial. We just have one. Even though we have x's and y's, there's no plus or minus sign separating them. Number 3 is a binomial, right? Separated by that subtraction. Number 4 is a monomial. Even though we have a minus sign, we only have one thing, right? That just means it's a -7. We just have one term. And number 5, again, is another trinomial. So I hope we're kind of okay with that jargon now of calling things whatever kind of nomial they are and letting that register in your brain that we're describing how many terms it has, right? All right, so standard form of any polynomial looks something like this. A sub n x to the n power plus a sub n minus 1 x to the n minus 1 power plus a sub n minus 2 x to the n minus 2 power plus dot 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 all the way down to a sub 1 x to the 1 plus a sub 0. So this may look really, really disgusting, but don't be intimidated. This is really just showing us a standard form of any polynomial. And what I want you to realize is, notice we always start with the highest power of x. So if this is x to the n, notice the next x term is x to the n minus 1, which means whatever this number is, if this was like x to the 7, right, then this one would be x to the 6th, right, and then x to the 5th. So that means we want it in descending order. So highest x down to the lowest x, which is just our constant term, right? We don't have an x on that last one. And then these a sub n's, that's just kind of our generic way of saying it's the number part of that term. So whatever this x to the n number is, this is the coefficient of that term, right? And whatever this power of x is, this is the number part of that term. So this is kind of our standard form, and we want to make sure that it's in descending order, which means our highest combined powers of the exponents down to the lowest. Okay, now the reason I say combined is because sometimes you'll have x's and y's. So if you have like an x and a y squared, then the combined powers would be 3, right? Because we have 1x and 2 y's, so that would be a degree 3 term, okay? So we always want to put them in order by our highest degree down to our lowest degree. Most of the time, for the purposes of this class, we're just going to deal with just x's or just y's, but I like to put that combined in there just in case you see one that has more than one term, okay? So a couple other things. The degree of the polynomial, okay, that is the highest degree term, okay? Highest degree term, okay? Again, this is that combined exponential power, okay? So on our example on the last page, that would have been our a sub n x to the n, right? That was our highest power of x, right? Or our highest degree term. Good. All right. And then our leading coefficient is basically just the number part of the highest degree term. Okay. The number part of the highest degree term. So for our example that was on the last page, since this was our highest degree term, the number part of it, or the coefficient, would have been a sub n, right? So let's go ahead and look at a couple examples, and then I'll let y'all try them, okay? So on our examples here, we want to write the polynomial in standard form. Okay, that means we want it in descending order, highest power down to the lowest, and then we want to identify the degree of the polynomial and the leading coefficient. Okay, so we want to reorder it and then identify these two things that we just learned about. So our highest power here, since we only have x's, makes it really easy. We just look for the highest power of x, which is our negative 3x to the fourth. So I'm going to go ahead and write this as negative 3x to the fourth. Then our next power of x would be negative x cubed, right? And then our x squared term, which is a positive 6x squared. Then our x term, which is a negative 2x. And then our constant term, which is a negative 6. Okay, so that is our descending order. Now we want to identify our degree, right? And we get our degree off of that highest power of that term. Okay, so this is my highest degree term. So I can identify that the degree of this polynomial is going to be 4, because that is the combined exponent from that term. Because here I only have one variable, right, which is x, and its exponent is 4. So this is a degree 4 polynomial, and our leading coefficient is the number part of that term, which in this case is a negative 3. Okay, everybody good? Let's look at one more, and then I'll have y'all try a couple, and then that's the whole section. So this one, again, highest power of x is, I'm seeing an x to the fourth. So this is going to give us 8x to the fourth. Then we do our x cubed, so minus 5x cubed. Then our squared term, always take the sign in front of the term with it. Okay, so this is a negative x squared. Then we have a negative 12x, and then we have a negative 1. Okay, so we have it written in standard form. This is our highest degree term. So that means that the degree of this polynomial is also 4, right? And our leading coefficient is the number part of that term, which in this case would be an 8. Okay, not too bad. All right, so there's 2 at the bottom of the page. Go ahead and pause the video and work them, and then we'll go over them. Okay. All right, so on the first one, when we write it in descending order, we should get negative 6x cubed minus 4x squared plus 4x plus 1, which means that our highest term, our highest degree term, is negative 6x cubed. So our degree would be 3, and our leading coefficient would be negative 6, right? On number 2, when we write it in the correct order, we should get negative x to the 6th plus 7x cubed plus 11x squared minus 9, okay? So our highest degree term would be negative x to the 6th power, and that means our degree is 6, and our leading coefficient here is a negative 1. Now notice there's not a 1 written there, but if there's no number written in front of variables, it's an implied 1. And since there's a negative out front, then it would be a negative 1, okay? All right, so that is all for properties of polynomials, and we'll see you on the next lesson. Go do your homework.